Today we are going to be starting stoichiometry. Now I want you to look at the front of your packet, and this looks very similar to when we had moles. Notice we have our mole town on this side, and then I added a second mole town on this side. Now if I scoot this up just a little bit, you will see that we have substance A and substance B. Now we've talked about in the past how we are working throughout this mole town, but I can go through it again quickly. So here we have our mole center. In order to get to volume, we have to use our molar volume, which is 22.4 liters. If we're going from moles to mass, we have to use our molar mass that's on our periodic table. Now if we're going from moles to particles, remember particles could be atoms, it could be formula units. Remember, formula units are ionic compounds. Okay, it could be molecules. There's a number of different things that particles consist of, okay? And in order to get there, we use Avogadro's number. Now this is just for one substance, and that's what we've done in the past. What we're going to include this time is going to another substance, and that is including our mole bridge. The way that you get from substance A to substance B is by using a mole ratio. Now if you look on your mole bridge, the mole ratio says the coefficients in the reaction. So what we have to get used to doing is looking at the coefficients in the reaction as a number of moles. So if we're trying to get from moles of A moles to B, the coefficient ratio that we're going to use will be our mole ratio. Now this is easiest to show through example, so make sure you have out a periodic table, make sure you have out a calculator, and then go ahead and write down these problems. And so this is going to be your first one, so make sure you pause the video to get this whole problem down. I'm going to show you how to do this. It says according to the equation N2 plus 3H2 goes to 2NH3, how many moles of ammonia will be produced if 4 moles of hydrogen react with excess nitrogen? So they gave us 4 moles of hydrogen, so that's what we're going to be starting with. So remember, this is going to be our train track method in order to do some conversions. So we're starting with 4 moles of hydrogen, and we want to get to nitrogen, okay? Now, if we look back at our mole bridge, we're starting with moles of one thing and going from moles to another thing. So this is only going to be one conversion, and we have to use our mole ratio to get there. So with 4 moles of hydrogen, what we want to do is we want to look, we want to get to ammonia. I'm sorry about that. Ammonia is NH3, so we're starting with hydrogen, and we want to get to ammonia. Whatever you're trying to get to, you're going to put on top. So here we have 2 moles of ammonia, and we had 3 moles of hydrogen. Notice that the 2 comes from the coefficient in front of ammonia, and the 3 comes from the coefficient in front of hydrogen. Now if we do out this math, remember you multiply what's on top and divide by what's on bottom. So go ahead and take out your calculator to do this math. And what you should get is 2.7 moles ammonia. Now here I have a number, I have a unit, and I have my substance. Let's try another one. Now this one is going to be more than just one step. This one's going from grams to moles, grams A to moles B. So this question says, what mass of potassium chlorate is needed to produce 0.50 moles of oxygen? Okay, so here I'm starting with 0.5 moles of oxygen. So what we're going to do, whatever we always start with, is going to go into the top left corner just like it has in the past. Okay, so if I'm starting with moles of oxygen, I'm trying to get to mass of potassium chlorate. What I want to do is I want to go back to my diagram here. So I'm starting with moles of substance A and I'm trying to get all the way to mass of substance B. So I'm going to do a mole ratio and then use my molar mass to convert. Now once I'm over here, I'm only using substance B. So for every 0.5 moles of oxygen, we have to look at the moles of oxygen that are in the equation. So that's what's going to go on bottom. So we have 3 moles of oxygen, and we're trying to get to potassium chlorate, so that is a 2 mole of potassium chlorate. Now I'm trying to get to grams. So I'm trying to get to grams, I have to add up all of the molar masses of potassium, chlorine, and 3 oxygens to figure out my molar mass that's going to go on top of here. Remember, if you put the molar mass on bottom, you have to get rid of, you put the molar mass up on top, you have to get rid of the moles on bottom, okay? So what I want you to do is I want you to figure out what the molar mass of potassium chlorate is going to be. I got 122.55 grams of potassium chlorate. Now you're going to multiply what's on top, divide through what's on bottom, and you should get 41 grams of potassium chlorate. Now notice, we haven't done this in a while, but notice how I am using significant figures. So if you need a refresher on that, go back and watch the significant figures video from earlier this year. Next, we're going to go from grams to grams. This is going to be an additional step that we are adding on. So it says, what mass of water is produced by burning 500 grams of methane? We want to go back to what we had here. So we are starting at mass, going to moles, going over to moles of another substance, and going to mass of another substance. So we're going to have 1, 2, 3 steps here. So we're starting with 500 grams of methane. And methane is CH4. Now if we look back at our diagram, next we have to go to moles of methane. So in order to get to moles of methane, we're going to put 1 mole of methane on top, and then use the formula mass, okay, of methane, which is going to be 16.042 grams of methane. Now if you go back to your diagram, the next thing is to do our mole ratio. So we're trying to get to water. There are 2 moles of water, so we're looking at the coefficients again, for every 1 mole of methane, because there is no coefficient in front of methane, so that indicates a 1. Now we're trying to get to mass of water, so we're going to cancel out our moles of water on the bottom and write in the molar mass of water. Again, everything that's on top you multiply, everything that's on the bottom you're going to divide. So we should be getting, let's see, 10,000 grams of water. Now again, this is for significant figure purposes. We only had 1 significant figure here, so we only need 1 significant figure here.